We are given that alpha and beta are roots of the quadratic equation x square minus px plus q is equal to 0. Therefore, the sum of the roots alpha plus beta is equal to p, and the product of the roots alpha beta is equal to q. Similarly, alpha raised to the power 4 and beta raised to the power 4 are given to be roots of the quadratic equation x square minus rx plus s is equal to 0. Therefore, the sum of the roots alpha raised to the power 4 plus beta raised to the power 4 is equal to r, and the product of the roots alpha raised to the power 4 times beta raised to the power 4 is equal to s. Now, the discriminant of the quadratic equation x square minus 4qx plus 2q square minus r is equal to 0 is minus 4q square minus 4 times 2q square minus r. This is equal to 16q square minus 8q square plus 4r, which simplifies to 8q square plus 4r. Now, q is equal to alpha beta as determined above, and r is equal to alpha raised to the power 4 plus beta raised to the power 4. Substituting these values, the discriminant is 8 alpha square beta square plus 4 times in brackets alpha raised to the power 4 plus beta raised to the power 4. This can be written as 4 times in brackets alpha raised to the power 4 plus beta raised to the power 4 plus 2 alpha square beta square, which is equal to 4 times alpha square plus beta square whole square, which is clearly greater than 0. Therefore, both roots of this quadratic equation are real. Also, r is given to be equal to alpha raised to the power 4 plus beta raised to the power 4, which can be written as alpha square plus beta square whole square minus 2 alpha square beta square. This can be written as alpha plus beta whole square minus 2 alpha beta whole square minus 2 times alpha beta square. Now, alpha plus beta is given to be equal to p, alpha beta is given to be equal to q. Substituting these values, r is equal to p square minus 2q whole square minus 2q square. And this is equal to p raised to the power 4 minus 4p square q plus 4q square minus 2q square. And this simplifies to p raised to the power 4 minus 4p square q plus 2q square. Moving all terms to the right hand side, this can be expressed as p square square minus 4q times p square plus 2q square minus r is equal to 0. Now, replacing p square with x, this result implies that p square is a root of the quadratic x square minus 4qx plus 2q square minus r is equal to 0. Now, the sum of the roots of this quadratic equation is 4q, and therefore, if the second root of this quadratic equation is alpha dash, then the sum of the roots p square plus alpha dash is equal to 4q, which implies that alpha dash is equal to 4q minus p square. Therefore, the two roots of the quadratic equation x square minus 4qx plus 2q square minus r is equal to 0 are p square and 4q minus p square. P square is clearly positive, and 4q minus p square may be positive or negative. And this is the required result.